Did you know that accurate rain prediction can save billions of dollars in economic losses caused by floods and droughts? According to the WMO Atlas of Mortality and Economic Losses from Weather, Climate and Water Extremes 1970 to 2019, there were more than 11,000 reported disasters attributed to these hazards globally, with just over 2 million deaths and $3.64 trillion in losses. TinyML solutions with sensor-fused inputs are now able to predict the onset of tropical rain or atmospheric rivers with high accuracy and can save some of these losses. Rain prediction is a critical problem, with over 90% of natural disasters caused by weather-related events such as floods and landslides caused by heavy rain. In the U.S., flooding caused by heavy rain is the second most common cause of weather-related deaths. In 2020, floods caused by heavy rain affected over 10 million people worldwide, causing an estimated $10 billion in damages. However, improvements in rain prediction models using machine learning and satellite data have increased accuracy by up to 25%, mitigating the impact of heavy rain and reducing the risk of severe weather-related events. AITS engineers have developed a low-code platform with templates to identify rain prediction using TinyML sensor-fused techniques and machine learning algorithms. The dataset for rain prediction contains date, location, the minimum temperature, the maximum temperature, the amount of rainfall recorded for the day in mm, the class A pan evaporation, the number of hours of bright sunshine in the day, the direction of the strongest wind gust, and the direction of the wind. With this dataset collected on a TinyML platform like cAInvas or www.tinyml.studio, it is easy to create a deep learning FFNN model to predict rainfall in the next 24 hours. With TinyML, rain prediction models can be deployed on small devices such as microcontrollers and weather stations, providing real-time data on weather conditions. The models can easily augment this to existing dataset and analyze this data to make accurate predictions about rainfall patterns, helping to mitigate the impact of heavy rain and reducing the risk of flooding and landslides. TinyML models developed with cAInvas can help improve rain prediction accuracy and provide real-time data to mitigate the impact of heavy rain, making it a valuable tool in weather forecasting and disaster prevention. Following URLs are referred to in this video. Check the description for the links. Contact us.